Hello, today we're going to take a closer look at what it means to factor completely. You have practice questions like this one here for the warm-up, so please factor this. When factoring this, we always look for a GCF, and these three terms do have a GCF of 2. So if you factor that out first, it would give us 2 times the quantity x squared plus 2x minus 3. And then we take the factor that has more than one term, and we see if we can factor it further, and we can. So we bring down 2 as one of the factors, and then the other 2 factors will be the binomials x plus 3 and x minus 1. Okay, so we're going to formalize the steps for factoring completely. Now, you will always check for a GCF no matter what type of factoring that you're starting with, whether or not it's a quadratic trinomial, like some of our examples today, or a 4-term polynomial. We always start by checking for a greatest common factor. Now, one thing that I mentioned, and we have done this before, is that we need to make sure that not only do we factor out a GCF, but we have to make sure that the first term has A as a positive number. Okay, A must be positive before we factor this into 2 binomials. We should never have a binomial factor that has a first term that's negative. It's not considered factored completely if it has a first term that is negative. So what that means is if we have a first term that's negative, we would factor out the negative with the GCF, or if we don't have a first term GCF, then we will factor out a -1, like this example here. So we're going to go ahead and start that. So I can see that there's a -1. There is not a GCF among the 3 terms. So my first step here would be to factor out -1, which would give me -1 times the quantity, n squared, minus 7n, minus 44. Okay, after we have done that, the GCF or the -1, and making sure that whatever trinomial or polynomial factor does not have a first term that's negative, then we're just going to factor the quantity using the skills that we've learned, either by grouping, quadratic trinomial, or if it's a special product. So in this case, we bring down the -1 factor, and this will factor to 2 binomials, n minus 11 and n plus 4 would be the correct answer. We can check that real quick. -11n plus 4n is -7n, and the first and the last term checks out, so this is our answer. Okay, second example. So the first step, remember, of all factoring is check for a GCF, and also at the same time you're checking that your first term is positive. So what would we factor out first for this example? And the answer is it has a GCF of 5, and we also must factor out a negative. So we're going to factor out a -5, and this would be -5 times the quantity m squared minus 10m plus 25. Now we're going to follow, when we look at the quantity here to factor, do we do it by grouping? No, because it's 3 terms. It is a quadratic trinomial. Does it happen to be a special product? And this one is a special product, but you could also factor it if you did not recognize that, and it would factor to m minus 5 times the quantity m minus 5. So the final answer would be -5 times the quantity m minus 5 squared. All right, third example. What will we factor out in the first step? And the answer is we would factor out a -3n squared. So when I factor that out, it would be times the quantity, n squared, plus 7n, plus 12. And now I need to see if this quantity is factorable, and it is. So to finish up the factoring, it would be negative 3n squared times the quantity, n times n is n squared, and then we would have plus 4 plus 3, because 4 times 3 is 12, and positive 4n plus positive 3n is 7n. So this would be our final answer. All right, so again, we need to check for the GCF and check to see if the first term is positive. So therefore, what would we do here? We would factor out a 5. We would not factor out negative 5 because the first term is positive. So the only time we need to worry about factoring out a negative is when the first term's not positive, okay? So once we factor out the 5, it would give us 5 times the quantity, 81z squared, minus 49. Now we need to check for any polynomial quantities that are bigger than a monomial. We need to see, is this factorable? And it is, because this is the first term, 81z squared, is a perfect square, and so is the last term, 49. So it's a difference of perfect squares. So we will bring down the 5 factor, and then the 2 factors for this special product would be 9z plus 7 times 9z minus 7. And again, you can check. 9z times 9z gives us the 81z squared. Positive 7 times negative 7 does give us the negative 49. This would give us positive 63 plus negative 63 is 0. So final answer does check out. All right, our final example is kind of throwing it back to factoring by grouping. However, we want to be in the practice of looking for a GCF and making sure that the first term is negative even with these. So what would we factor out in the first step? The answer is 3, because all 4 terms have a common factor of 3. So this would give us 3 times the quantity, x cubed minus 2x squared minus 5x plus 10. And I always say just double check yourself as you go, redistribute, make sure it would give what's above. All right, the next thing that we're going to do is inside the quantity, the 4 term, we're going to factor by grouping. So remember, we separate the 2 groups. And so in the next line, we're going to bring down our monomial factor 3. It's not going to change. And then we go group by group. So this first group, the GCF would be x squared. So we factor that out and get x squared times the quantity x minus 2. For the second group, and I meant to tell you, making sure when you separate it that we can see the minus or the plus in front of the first term. So in the second group, technically its first term is negative, so we need to factor out that minus along with the 5 that is the GCF between the two, which would give us minus 5 times the quantity x minus 2. And again, if we redistributed negative 5 in, we would get what is above it. All right, finally, factor by grouping, we look at these 2 terms, and they have in common a binomial x, quantity x minus 2. So we bring down the 3, and then that would be times the quantity x minus 2 times the quantity x squared minus 5.